AuroraLabs has put together an OTA, or over there update cost simulator, with Guidehouse Insights help putting this project together. But Aurora actually has this up on their website as a resource, and I've looked at it and talked. And this is a phenomenal, actually, tool. It does a calculation of number of ECUs in a vehicle, the fleet size, lines of code, et cetera, et cetera, et cetera, to do a calculation of what a full image update or a line of code update or a binary update would be for over-the-air updates. And I like the tool because it actually puts a line in the sand. There's been a lot of conversations of what the costs are of a recall, or what the costs are of doing an OTA in the field and getting software issues corrected by doing OTAs. And this is a good tool to put a line in the sand. As I said, there are some assumptions in it, as we know that the OEMs have done agreements with the wireless carriers so they get lower data rates than probably what's been publicized here. And there's also some back-end assumptions in here. But for a line in the sand and somebody actually putting this out there showing what a figure is to do a OTA and do a software fix, this is a phenomenal tool that Aurora has done, and I applaud them. As I look at this, you can say, as an example, if you have OTA, you have to do a software update. It's going to cost you, let's say, $1.2 million. What my assumption is, and not really assumption, but a rule of thumb, is if you look at what we're doing at VCubed, where we have all the tools across the board to eliminate and to minimize the number of software issues, then again, it's back to what we've talked about in the past. Build your foundation. If the foundation is good and you have the tools in place, then you can minimize the number of OTAs you're doing. The thing about OTAs is trying to capture that I'm curious about is you have software updates, but software updates can fix the hardware issue. Software updates can fix a mechanical issue. I'm more curious about the true software issues residing in the code, and understanding when you're doing an OTA, how much of it is actually publicized of what you're fixing for issues and bugs residing in the code. And that's what I'm more curious about. And if you use this tool alongside of understanding of what the OTA is addressing, you can understand what your software issues and your software quality issues are. And as I said, if you look at VCube's tools, you can go back down in your code scroll and go all the way back into doing static analysis and unit level testing. Or you can go into a cover and the quality scrolls and work with cover and showing exactly where you're at. Or going further and using secure scroll with fit and doing fault injection tools and probe tools, doing AutoZar timings, and etc. We as an organization can't really, in the past, been able to calculate what the true cost of a software issue is. That's why I really like the Aurora tool to have and doing the OTAs. As we look at this, we can sit here and understand what we're looking at and trying to say, this is what's preventive, but we're not capturing. We don't capture the true cost of what a software issue is. Because as I've said in the past, when you have a software issue, there's many aspects to getting it rectified. And it's boiling down to getting the software in the vehicle to fix the issue. It's the quality people that you burn out because they have to report and record it on the issue to the OEM. It's the engineers burnout that you have to deal with because they have to go back and be pulled away from their current project to fix an old project. And that's burnout also. So there's an excessive amount of cost that this tool doesn't actually capture personally, but it is a good line in the sand saying this is where they're at for a cost. Yeah, with the tool that AuroraLabs and Insight has put together, it basically draws a line in the sand. It gives us the ability to have an understanding of what an OTA is, an approximation of cost. It doesn't give you an actual definite cost because, as I stated, the OEMs have worked with the carriers to get lower data rates than what the consumer rates are. And I believe that the calculation from this calculator is actually from the consumer data rates, which, as I said, realistically, you take this calculator and OEM can put their real numbers in that they know that are private to them, and they can put in true cost. But back to my point is understanding the cost of an OTA really doesn't do much unless you're looking at how to rectify it. Why are you doing an OTA? Why do you have a software issue to begin with? Let's look at that cost. No matter what the cost is, it's too much, especially if we could have rectified it and solved it earlier in the program. Everyone says shift left mentality. We want to shift left and we want to catch the bugs earlier, do testing earlier and more often, and get those bugs solved and resolved. But as we see, the OTAs, especially Tesla's burning out their memory because they're doing too many OTAs. They're constantly doing software updates and burning out the memory because there's so much ability for the RAM to be reflashed. And once it's reflashed to an excessive amount, it doesn't work anymore. Then you have to recall the vehicle anyway for a hardware issue. So let's talk about the foundation. Let's work with going back and looking at the V curve and applying tools as V cubed has in our library to do static level analysis, to do unit level analysis, to understand quality responsibilities for ISO 26262. And these are things that we look at and work toward. This is what we do as an organization. We have the ability to have the tools. But even furthermore, from a VQ perspective, we look at and have in our ability, we do functional safety documentation. We can do the embedded software design and development if you need, or if you do an embedded software verification, on target verification. We covered the V curve across the board. And as you can see, it's across every industry. Automotive's not special by any means by trying to figure out how to have good code. We've seen that if we see the errors of bad code and bad infrastructure and bad foundations by the ability for the Russian hackers to take down the Colonial Pipeline and our meat productions. Foundations are weak in the software world. It's a well-known fact. And now that the press has gotten a hold of it, because we've seen massive targets being taken down in the US, we need to make sure that our foundations for our autonomous vehicles are at least stable and secure. Otherwise, my prediction for 15 to 20 years from now is hackers are going to be working against General Motors to take down their complete fleet at one time. So as we work on this, again, we have to go back and build our foundation. Our foundation is our core to our architecture. It's basically intelligent verification. We have to do intelligent development. This is simple. These are processes that we have in place for other industries. We just need to work at carrying them over into automotive and getting the application and getting some exposure. I don't want to see exposure vehicles being shut down because of software bugs. That's a negative. That's something that's not going to be beneficial for any of us. So again, back to the foundation. Go back. How many automotive manufacturers and tier ones are working to this type of V curve, to where they're applying everything to meet ISO 26262? That's the question. We're here at VCube to help us. But as I pointed out, as I started the conversation, AuroraLabs will tell you how much it costs in the end if you don't do it right, which is fine. You need a calculator to tell you how much it's going to cost to not do it right. You have one now. So put the foundation together, create the foundation. Come reach out to V Cubed. We will get you to where you need to be in the quality structure, as we've done with the number one and JD Powers on-die motors.